All right. Today I just have one topic. That's just the rational equations. We're gonna meet next Monday to go over the other two topic, rational inequalities and models involving rational expressions. So we'll do that on Monday of the October, which is what, October, let me see, that would be October 5th, okay, and then I think we have the exam on October 7th, okay. So let me just go over the rational equations. Now, rational equation is very similar to the rational expression, except now you have to solve for unknown. Okay. There are a couple of things that we have to do when you solve the rational equation. That is, you want to eliminate the denominator. Okay. So in other words, that you are not trying to simplify anything. You're trying to solve for unknown x. Okay. So the only thing that is going to be similar to the rational expression is going to be coming up with the least common denominator. Okay, so I'm going to give you an example. So the rational equation is, ultimate objective here is solve for unknown. Okay, and the second is find least common denominator. Okay, so let's start with the example here. Okay, this is going to be a short video, so I'm just going to give you some examples, and then I want you to do some practice on this. Okay, so you got 3 over x squared minus 4x plus 3 plus 6 over x squared minus 2x minus 3 equals to 5 over x squared minus 1. Okay, let's take a look at this example here. Now, the first thing that I'm going to ask you to do when you solve it, rational equation, I want you to make the denominator in factor form. So here we have x squared minus 4x plus 3. We're going to split this, x and x, then the 3 and 1. But they both has to be negative, right? Because if you cross multiply, you get negative 3x. Cross multiply this way, you get minus x. When you add those two, you get minus 4x. So we can rewrite the bottom denominator for first term as the x minus 3 times x minus 1. We're going to do the same thing the next term over here. So if I see the x squared minus 2x minus 3, same thing, I have x and x. Here, same 3 and 1. But this time, I'm going to have a minus 3 here and a plus 1 there, because if I cross multiply this way, I get minus 3x, and the cross multiply this way, I get just the x. So you will get minus 2x in the middle. So if I rewrite it in the factor form, I have x minus 3 times x plus 1. Okay. And is equal to 5 over, now x squared minus 1 is a difference of a square, so we're going to write it as x plus 1 times x minus 1. So once you find the LCD, okay, And then you want to do is you multiply everything, multiply all sides with the LCD, so that we can get rid of the fractions there, right? So here we go. I want to look at the each factor form denominator. So in order to find the LCD, you're going to find the one that is going to be not, okay? You're going to take the all the common ones that is going to be belong to that, and then you're going to also have to take the terms that is not belong to the each term. So we're going to have to look at the each term and the denominator here. So you got x minus 3, x minus 1, x minus 3, x plus 1, and x plus 1, x minus 1. So in any case, since these two terms have x minus 3, I'm going to use that. So I'm going to have x minus 3. This one has x minus 1 and this one has x minus 1, but this one doesn't have it, so I'm also going to need that, x minus 1. This one has x plus 1 and this one has x plus 1, but this one doesn't, so we're going to have x plus 1 there. So how do we know which one to select? Usually the way we're going to select the denominator, the LCD, is you just look at the denominator, okay, and select the terms that, if you have all the terms already there, then you don't have to pick. So if, let's say, you still can pick, right, because you want to get rid of it, but when you look at the denominator, okay, you select all the terms, not the duplicates, okay, whatever the term that you have, okay, you're just going to, select them. So the first two terms, we had x minus 3 and x minus 3. We are not going to put 2 of x minus 3 here. We're just going to put 1. And this one, x minus 1 and x minus 1 over here, we're just going to put 1. Okay? So now we're going to multiply everything by this. Okay, so now I have 3 over x minus 3 times x minus 1. Then the second one, 6 over x minus 3 times x plus 1. And the third one, 5 over x plus 1 times x minus 1. So we are going to multiply entire equation, everything. Sorry about that. So everything by that LCD, x minus 3 times x minus 1 times x plus 1. Alright, so far so good. So we're going to multiply each to each term over here. So let's look at the first term. So if you look at it, x minus 3 and x minus 1, they cancel out. That's just giving us the x plus 1 on the first term. So you'll have a 3 times x plus 1 plus the next term you're going to go away. Yes, you're going to make them x minus 3, x plus 1 go away. Okay, so then you're just going to get x minus 1. 6 times x minus 1 is equal to, here x plus 1 and x minus 1 go away, you just get x minus 3. Alright, so as you can see, your denominator is gone. So now what you have to do here is that just use the distribution property, multiply them out, and combine the terms. Okay, everything, put them all together and put x's on one side, because this is a linear equation. X is on one side and constant is going to be on the other side. Okay, so here we have what, 3x plus 3 plus 6x minus 6, and the 5x minus 15. Let's combine these. So I have a 9x, then I have a 3 and negative 6, I have a minus 3, and I have a 5x minus 15. So I'm going to subtract 5x from both sides. Oh, sorry. So then I have a 4x minus 3 equals 2 minus 15. Or is it? Plus 3. I'm sorry. I haven't done that yet. So now I'm going to add 3 on both sides. I was going too fast. So then I have a 4x equals 2 minus 12. And you divide by 4 on both sides. So x is going to be equal to minus 3. Now, the important thing here is that you're going to have to plug in this minus 3 into an equation. Back to this original equation here. And make sure that you get the correct answer, meaning that when you plug this in, left is equal to the right. So if you don't do that, then this might not be the correct answer. Then there's no way of you knowing it. So I'm going to plug that in, and I just want to make sure we got this one correctly. Okay, so let's just do that. So we're going to plug in x equals to negative 3. That's what we found. So we're going to plug that in. I mean, you can plug into the original equation over here, and or you can do the second factor form. It doesn't make any difference. Okay. So here the first term is going to be 3 over. And then I have minus 3 times minus 3 minus 1 plus 6 minus 3 times minus 3 plus 1 equal to, is it 5 over minus 3 plus 1 and minus 3 minus 1. Okay, so let's take a look. So we got 3 over, this one's going to be a minus 6 times minus 4. This one we have what, minus 6 times minus 2. Is this equal to 5 over minus 2 times minus 4? Okay, so we're just going to have to find the factors. So the first term is going to be 3 over positive 24 plus 6 over, this is going to be a 6 times, minus 6 times minus 2, we get positive 12. Is this going to be equal to 5 over 8? So I'm going to combine these two by multiplying the second term by 2 here. Okay, so that will give us the 3 over 24 plus the 15 over 24. Is this equal to 5 over 8? So if I combine these two, I have 18 over 24. Is this the over 5 over 8? So if I divide top to bottom by 6, like this. Did I make a mistake here somewhere? Let me see. I need to go back and make sure that this is the correct answer, because otherwise it doesn't look right. Okay, so we need to check this out here. Let me see. Minus 3, that's negative 6. Oh, that's not 15. That's supposed to be 12. Sorry about that. Over here. I don't know why I said. Maybe I was going too fast. So this guy here is supposed to be 15. Okay. So now if I divide the both sides, top to bottom, by 3, okay, then I get 5 over 8. And that's the same as on the right hand side. So x equals to minus 3 checks out okay. So we can say the answer is going to be minus 3. So here's going to be the key that we need to understand here. Okay. I'm going back to the beginning. The rational equation, what we are doing here is that we're going to solve for the unknown. We are not simplifying or anything. I want you to find out what x is. Okay, unknown. The second thing here is that in order to make this thing, this solving rational equation easier, we have to find the LCD, and you're going to have to multiply you found the LCD to all 3 sides. Okay. The other thing that we're going to have to remember is that we will have to, come up with the LCD. In order to come up with the LCD, you look for all the denominator. You just write everything that you see in there, except you don't want to write the duplications. Okay, so everything you just write it once that you see on the denominator, and that's going to be the quantity that you're going to have to multiply all 3 sides. Usually 3 sides, and then then you solve for x or unknown, and then you have to make sure that you check your answer. All right. Now there are 3 things that it's not always that you will get the answers like this. Sometimes you don't get one. Okay, so I'm going to show you that. Okay. So here is the example that once you find the solution, and when you go back and plug it in, it doesn't make any sense. Okay, so here's what we have. I have 5x plus 4 divided by x squared minus 16 minus 4 over x plus 4 equals to 3 over x minus 4. So here it's pretty easy. X squared minus 16 is the difference of squares. I can rewrite this. Then I have x plus 4 times the x minus 4 minus 4 over x plus 4 equals to 3 over x minus 4. So now the LCD that we found is going to be everything that you see at the denominator, except you don't write the duplications, right? So you got x plus 4, 2 of them, you just write once. And you got x minus 4 and 2 of them, so you just write once. Okay? So we are going to multiply the entire this thing by that quantity here. So x plus 4 times the x minus 4. So let's look at each term. So first term, they both go away, right? Because x plus 4 at the bottom, x minus 4 at the bottom, and same thing over here. So the first term, we're just going to get 5x plus 4. Okay? Now the second term over here, x plus 4 goes away, cancels out, so it's giving us the minus 4 times x minus 4. And on the right hand side, x minus 4 cancels out, that gives us the x plus 4. Okay, so denominator is gone. Now we're going to have to use the distribution property. Okay, then multiply these out, and then we're going to combine the x terms and solve for x. So here's the 5x plus 4. If you multiply this out, I will get minus 4x plus 16. Okay, is equal to 3x plus 12. Okay. Let's combine the x term here. So we got 5x minus 4x, we got x. Then we got 4 plus 16, you get 20. Equals to 3x plus 12. Now, I'm going to subtract x. Okay, so then I have 20 equals to 2x plus 12. Okay, now then we're going to subtract 12 from both sides. So on the left hand side we get 8. On the right hand side is a 2x. Now we're going to divide it by 2. So we get x equals to 4. So now we're going to have to go back and the original rational equation, see if this thing makes sense. So we're just going to plug this in. So we're going to try the x equals to 4. So let's plug that in. 5 times 4 plus 4. 4 squared minus 16 minus 4 over 4 plus 4. Is this equal to 3 over 4 minus 4? But here's the problem though, right? If you look at the down here, this guy is here, and that guy over there, that's going to be, what is that, 24 divided by infinity. And this is going to be 3 divided by 0. You cannot divide by anything by 0. Because this both has a 0 at the bottom. So that doesn't make any sense. So in this case, even though we came up with the answer, x equals to 4, okay, we're saying that this problem has no solutions, okay? Has no, so you need to write this on the test if you have something like this. Or you can just say 0 with the line goes through it, okay? That's another way. Or you can say just the, something like this. That's also indicating that there's no solutions. Okay? So this is one thing that, we need to be aware of. Because you're solving for x, you expect, some kind of values. But sometimes that value does not mean that it's going to be your solutions. Meaning that you're going to have to go back and try at the whatever the solution that you got, and you go back and put it back into the your original equations and make sure that left is equal to right. Now here you might say, well, isn't that like undefined is left equal to the undefined right? No, that's not true, because undefined is not a value. Okay, so here we are looking for some sort of a value on the left and a value on the right, and that has to be equal to one another. Okay, if you don't, then you don't have solutions. Okay, so that's what we have here. Now, so I'm just, I showed you two cases here. One is that, you solve the rational equations and you found the solution and I plugged back into the original equations, and then I found out that left is equal to the right of the equation. So that's the good equations. The other case, I found out that's not true. So that means that we don't have a solution there. I want to, so thus far when you solve this rational equation, everything happens to be a linear equation. So the last example that I'm going to show you here is that sometimes you're going to end up with the quadratic equation. So let's just talk about that. So here I have x plus 3, then I got x minus 1, plus x plus 5 divided by x is equal to 3x plus 1, okay, and x minus 1. So here LCD, let me just use the different kind. So the LCD here is the x times x minus 1. Okay? No duplicates. Okay? So we are going to multiply everything by that. X times x minus 1. So the first term, x minus 1, cancels out, but it gives us the just x plus 3 times x. So x times x plus 3. Plus. Second term, x is cancelled out, but we still have x minus 1, so we have to multiply that. So I have x plus 5 times x minus 1. On the last term, x minus 1 cancels out, so we're going to have to multiply x times 3x plus 1. Alright, now we're going to multiply these out. So you got x squared plus 3x plus, now we're still going to have to do this, x plus 5 times the x minus 1. I'm going to come back to this one. On the right hand side, I have a 3x squared plus x. So we're going to multiply the x plus 5, x minus 1. Let's just use the box again. So x 5, that's plus 5. And then x minus 1. So we have x squared 5x minus x, that's minus 1. And then minus 5. So I'm going to write that. I have x squared plus 3x plus x squared plus 5x minus x minus 5 equals to 3x squared plus x. Okay, so this term over here, x squared plus 5x minus x minus 5 is coming from this guy here. Okay, so if I combine some terms over here, so let's just combine the x squared term over here and the over here. So that gives us the 2x squared. And then we combine the 3x over here, okay, and 5x here, and the minus x there. So that will give us the, 7x plus 7x. And then I have a minus 5 equals to 3x squared plus x. Now remember, this is a quadratic equation, so we're going to have to put all the terms onto the other side, and I have to make the one side equal to 0. So what we're going to do now is that we're going to subtract everything here, so minus 2x squared minus 7x plus 5. And we're going to do the same thing over here, minus 2x squared minus 7x and the plus 5. So that means the left-hand side is going to be equal to 0. So if I combine some of these terms over here, you got 3x squared minus 2x squared, you get x squared. And then you got x minus 7x, you got negative 6x then. And then plus 5. So here we're going to have to factor this. So I have x squared minus 6x plus 5. So let's factor this, x and x. Now here I'll probably go like 5 and 1. They're both minus. So you got minus 5x here, you got minus x over there. So minus 5x plus minus 1x, you get minus 6x. So that's a good combination. So here we're going to have on the factor form, we have x minus 5 times x minus 1. So for x, that means that 0 equals to x minus 5. So x has to be 5. Here 0 is going to be equal to x minus 1. So x has to be 1. Now, because they are quadratic equation, we were expecting two different solutions. Okay? Now, we're going to have to try, okay, whether these two equations going to be the both solutions. But if you're going to look at the x equals to 1, this guy over here, and if you plug into over here, this doesn't make any sense over here. Because 1 minus 1, you're going to get 0. Then 4 over 0 is undefined. That's going to be a similar case that what we just did. So obviously that the x equals to 1 is not going to be your answer. Okay? And if you plug in x equals to 5, it will work. Okay? Because if you do that right now, let me just bring this up a little bit. So let's try the x equals to 5. Then I have a 5 plus 3 over 5 minus 1 plus the 5 plus 5 over 5. Is this equal to the 3 times 5 plus 1 divided by 5 minus 1. So you got 8 divided by 4 plus the 10 over 5. Is this equal to 16 over 4? So that's just the 4 here on the right hand side. And that's 2. Okay? And that's 2. So that would be 4 is equal to 4. So x equals to 5 checks out okay. So even though you have two solutions for this rational equations, the other questions we have, it just didn't make any sense because whenever we plug that value in there, it was the linear equation, so we were expecting just one solution, but when we plugged that in, it didn't make any sense. There's no solution. So in this case, we have two solutions because we had a quadratic equation, but happens to be that one of them is not a solution. This can happen like this. Okay, you can have a both solution, but in this case, happens that the one of them is not a solution, but the other one is. Okay, so just a recap. When you're talking about the solving rational equations, we want to make sure that the first thing that you are going to do is we are going to solve for x, unknown. And then we want to find the LCD to eliminate the fractions, get the bottom denominator. And then once you eliminate the denominator, we're going to solve for x. If it's going to be linear equation, we put everything on one side and the x on the other. Then solve for x and make sure that you go back and check your answer. If it doesn't make any sense, then you will have to tell me this is not a solution. If it's going to be a square quadratic equation, for example, then you're going to have to put everything on one side, the other equal to 0, and solve for x. Okay. Then again, you're going to have to plug back in the whatever you found value as an answer. you're going to have to put it back in there, make sure that, you know, it makes sense. If it doesn't, then that's not a solution. All right? So that's how we're going to solve the rational equations. Okay, so we have a couple of more topics, then we will talk about that coming up next week. All right? All right, see you guys. Bye-bye.